In this video, we're going to talk about one of the most important topics of the course, and it's even a topic that is going to follow you through most of your calculus course next semester. We're going to look at the average rate of change of a function. So the first thing we're going to do is look at examples where we want to know how fast one quantity is changing with respect to another. We're going to use that to define the average rate of change of a function, and then we're going to compute an example. So let's look at some questions about functions that we might want to consider. So first one is, say you are walking and you notice that your first mile takes 15 minutes. The question is, how long would you expect to walk in 50 minutes? Our second question is, suppose that you are saving money for a purchase. In 3 months, your savings goes from $100 to $250. Then the question is, how long do you expect it to take to have $800 in savings? In both of these cases, we are talking about functions. In the first problem, we're talking about distance as the output, time is the input. So distance is a function of time, and of course that time is being measured in minutes. And for the second one, our output is the money saved, our input is the amount of time that goes by, and the time, of course, is measured in months. So in each of these cases, it is going to be helpful to know how fast your quantity is changing so that you can solve the problem. So for what I mean by that, how fast your quantity is changing, is in the first one, how many miles per minute are you covering? And then how many dollars per month are you saving in the second problem? And so each of these is what's called a rate of change of our function. So let's take a look at that first problem. Notice that our rate of change is 1 mile covered in walking per 15 minutes of walking. And so if we want to compute how many miles per minute that is for the rate of change, we get 1/15 miles per minute. So if we want to know what's happening in 50 minutes, we take 1/15 of a mile per minute, we multiply that by the number of minutes, in that case this is 50, and then we multiply that out to get 3 1/3 miles. In the second problem, it's a little bit different because here we want to know how much time. We don't want to know what the output is going to be in a given amount of time. Here we know between 0 and 3 months our savings increases by, well, it increases by whatever we had at the end and then subtract out what we had at the beginning. So at the end we had $250, at the beginning we had $100. When we subtract those, we get $150. That's the amount that we saved in those first 3 months. If we want to know the rate of change of that savings, we take that $150 that we saved in those 3 months, divide that by the amount of months, and that gives us $50 per month. So remember, in that second problem, we're trying to figure out how much time has gone by. So we're going to let x be the amount of time that we wait. That's what we're trying to solve for. Since we get $50 per month, if x is the amount of time, we multiply x times 50 to get the amount of savings that we get. Plus, of course, that $100 that we had at the beginning. So we take the $100 we had at the beginning, add on to that the amount that we saved in those 3 months. And since we want that to be $800, we set that quantity, 50x plus 100, equal to 800. And then this becomes a pretty straightforward equation that we can solve. And when we solve for x, I won't bore you with the details, we end up with x equals 14. And since our units are in months, that is 14 months that it will take to get from $100 to $800. So if we look at this average rate of change, the first thing I want to note is that it was quite helpful in solving both of those problems, and the process that we used in each problem was more or less the same. We find out how much the output variable changes, right? That becomes our numerator. We figure out how much the input variable changes, that becomes our denominator, and then we divide the two. We divide the change in output by the change of input. And so if we want to look at that as an algebraic formula, if f is a function, the average rate of change of f between input x equals a and the input x equals b is, well, our first step is to find out how much the output variable changes. And the way we find it is we take the output at the end, that's f of b, subtract the output at the beginning, that's subtracting f of a, so f of b minus f of a is how much the output variable changes. And then for how much the input variable changes, we do the exact same thing with the input variable. We take the input variable at the end, that's x equals b, and subtract off the input variable at the beginning, that's x equals a. So we get b minus a in that denominator. So if we want to apply that to the function given by f of x equals x squared, here's a function given as a formula. If we want to find the average rate of change between x equals 4 and x equals 7, well, the first thing we're going to do is find the output at x equals 7, the output at x equals 4, and then subtract those two. So our change in output is f of 7 minus f of 4. Let me see, f of x is equal to x squared, so f of 7 is 7 squared, f of 4 is 4 squared. And when we subtract those, we get 49 minus 16, which gives us 33. So that's our change in output. Our change in input is very straightforward. We just take our ending input, that's x equals 7, our beginning input, that's x equals 4. We subtract those two to get 7 minus 4 is 3. And then we take for our average rate of change, we take our change in output, which is 33, divide that by our change in input, which is 3, to get 33 over 3, which is 11. So now it looks like you're ready to look at the first set of activities for average rate of change. That's the one that's called velocity on the PDF file included with this video.